All right, kids, in Algebra 1, it's almost time for our benchmark test. We've got this and probably one more video of review after this one. After this video, we will have covered everything that's going to be on your benchmark test. So inequalities practice, we're going to work on practicing solving, graphing, and writing inequalities for word problems. Let's start with some examples where we're solving and graphing. All right, so let's solve a couple inequalities here. I have had to force your hand here on a couple of these problems to where you're going to have to flip the symbol because sometimes you won't be able to avoid that, and that's what we're going to practice with real quick first. So let's just take this first one. -3 times the quantity x plus 2 is at least 8 or is greater than or equal to 8. All right, so I'm going to start off by I have to distribute here. Why do I have to distribute? Well, I mean, I could divide by -3, but that 8 is not divisible by -3. So I'm going to distribute and get -3x minus 6 is greater than or equal to 8. Now I have a two-step inequality, so I'm going to reverse subtraction or addition, in this case subtraction, by adding 6 to each side. And I get -3x is greater than or equal to 14. I divide both sides by -3. What kind of 3? -3. So it's x is less than or equal to -14/3. Now the graphing of that is not difficult. I'm going to do it right up here. I'm going to put -4, -3, -2. Just think about how your negatives are numbered. And all right, so -14/3 is -4, -4, and 2/3. Which is -4 and 2. Oh, look, you kind of messed that up there, didn't you? We got to fix our number in our number line. Make it -5, -4, -3 this way. And here's -4 and 2/3, right about there. And it's really x is less than. So a lot of kids tell me, oh, you can't check inequalities. Sure you can. Pick a number that's covered with the solution set, but that is not on the actual circle. So we're going to use -5 to check it. All right, plugging in a -5, I have -3 times -3, when I do the math inside the parentheses there, is greater than or equal to 8. I get 9 is greater than or equal to 8. I know I did it right. So remember, when you check, you pick a value that is in your solution set but is not actually on the number line or on the circle itself. Let's look at 2. I'm going to use orange for this one. This one is nice and straightforward. I had a very specific reason for wanting to do this one. I'll show you in a moment. We're going to subtract 9 from each side to get the 4m by itself. 4m is greater than -30. We're going to divide both sides by 4. What kind of 4? A positive 4. Do not flip that symbol around. And there's our solution. Now I'm going to use my number line here. All right, -15/2 is -7.5. So let's put -8, -7, -6. This time is an open circle at -7.5 and shade it up for greater than. Remember again to pick a number that fits the inequality solution, but isn't at the circle, because we couldn't pick a -7.5 if we wanted to, because it doesn't actually fit here. It's greater than, it's not equal to. So I'm going to pick -6. So 9 plus 4 times -6, is that greater than -21? 9 plus -24, is that greater than? Nope, not greater than or equal to. Let me fix that. Just greater than -21. And indeed it is, because we get -13 is greater than -21. Check. I know I did that right. And I'm almost completely out of space, but that's okay. Let's switch colors. Let's use some green on this one. So this time, we've got 3 times the quantity. We're going to distribute here. So I'm going to get 3t minus 3 minus 4t is less than or equal to -5. 3t minus 4t, combine like terms. This is what you guys often forget and then get confused. Don't forget to combine like terms. Now it's only got 2 more steps. Add 3. Opposite of t is less than or equal to -2, and then multiply both sides, or you could say divide both sides by -1. T is greater than or equal to 2. My graph for this would be, and I'm going to have to number it above because I am completely out of space. T is greater than or equal to, so solid circle, closed circle, shaded up. You're going to have to check that one on your own because this video, I don't want it to get too long. Let's move on to a couple more examples. So remember, in this circumstance, you had to flip the symbol on 2 of them, on 1 and on 3. Notice you did not flip the symbol here, even though this 30 is negative, because I didn't divide by a negative. It's only when I multiply or divide by a negative that I'm flipping that symbol around. Let's try a couple more. You guys pause it and try it yourself, and then restart the video or continue the video, unpause if you will, but I'm going to jump right in and get started. Now on this first one, I have 6n minus 1, that's number 4, so the fourth one really, is greater than 3n plus 8. Now if you stick to the rule I taught you in class or in your notes, in one of your videos, about getting rid of the smaller value of the variable, 3 is smaller than 6, you will not have to worry about the negative situation in the flippage. You won't have to worry about flipping. Unless you're a gymnast, in which case you probably should have to think about flipping. But I'm talking about symbol flipping here, and I'm not going to need to do that because all the way down, I just followed the math rules just like an equation, and it's still true. I didn't have to multiply or divide by a negative because I followed Miss LeCompte's fancy rule of always dealing with the smaller value of your variable first. Let's do the same thing on this next one. Negative 4w and minus 6w. Minus 6w is smaller. Get rid of negative 6w by adding 6w to both sides and watch what happens. You no longer have negative w. I have 2w plus 8 is greater than or equal to 10. I'm not going to have to worry about any flipping. Subtract 8. 2w is greater than or equal to 2. Divide both sides by 2. What kind of 2? A positive 2. No symbol flipping necessary. Going back to do my graphs. Remember, put 3 notches on minimum, and really that's all you need. So 0, 1, and 2, solid circle, shaded up. For the other one, again, 3 digits, 2, 3, 4 in this case. Open circle, shaded up. Make sure you can see some daylight in that circle as opposed to this filled in one over here. See some daylight in there. All right, we got 3 word problems we're going to try, and then we're going to be done with this video. Okay, write an inequality for this circumstance. Let's get started with this one. Keith has $500 in the savings account at the beginning of the summer. The summer. I miss it already. He wants to have at least $200 in the account by the end of the summer. He withdraws $25 each week for food, clothes, and movie tickets. Write an inequality that represents Keith's situation. How many weeks can Keith withdraw money from his account? Justify your answer. Well, let's start with defining a variable. We're going to use the variable W to be number of weeks. So Keith, not Kyle, starts with a K. Give me a break. Keith has $500 and he's spending $25 per week. When we see an amount of money per something, it's usually multiplication. So when I say $25 per week, we have 25W. And we want to know, he wants to have at least, he wants to have 200 or more at the end of the summer. There's our inequality with W representing number of weeks. Now I can go through and subtract 500 from each side to solve for W, because before I can get W by itself, I got to get minus 25W by itself. 200 minus 500 is negative 300. Divide both sides by negative 25. What kind of 25? Negative 25, which means I'm flipping the symbol. Sorry, I'm in a goofy mood today. Flipping the symbol. So W is less than or equal to 12. So justify your answer here, okay? How many weeks, excuse me, for how many weeks can Keith take out that $25? Well, he could do it for 12 weeks, and he'd have exactly $200 left. But reasonably, if he wants to have at least $200 left, he could do 11 or 12 weeks, but no more than 12 weeks. And if you look at your inequality symbol right there, that's exactly what symbol that is. That's a less than or equal to is a no more than. Could be equal, but it can't be more than, must be less than. So no more than 12 weeks. Keith should probably get him a job, but, you know, just saying. Let's try a couple more. These are geometry applications. Now, I know you're thinking, what do you mean geometry applications? Come on, LeCompte, we haven't learned geometry yet. Well, you learned pre-geometry. That's what pre-algebra really is, pre-algebra and geometry. Let's read it before you panic. In a community garden, you want to fence in a vegetable garden that is adjacent to your friend's garden. That means they're touching. So here's your friend's garden, here's your garden. Your friend is quite a bit further along than you are, but it looks like you got more space. You have at most 42 feet of fence. What are the possible lengths of your garden? Okay, so you have to put a fence all the way around, so we all are accounting all four sides. The perimeter of a rectangle, remember, is 2 length and 2 width. Well, we already have the width, because if this is 12, this side is also 12. So what we don't know is the length, and I'm going to call it x. So for perimeter, we have at most 42 feet of fencing. So it has to be smaller than or equal to 42. Let's do 2 times the length, which is x, plus 2 times the width, which is 12. And there's our inequality. 2x plus, and 2 times 12 is 24, so 2x plus 24 is less than or equal to 42. Why is it less than or equal to? Well, it says at most, and think about it. If that's all the fencing you have, you can't use any more than 42 feet, so it has to be smaller than or equal to 42. Now I'm going to solve it. I'm going to subtract 24 from each side, giving me 2x is less than or equal to, is that 8? 18. Sorry, it took me a second to subtract 42 minus 24. Depressing, I know. All right, divide. X is less than or equal to 9. Okay, so what are the possible lengths of your garden? 9 feet or less would be my answer. Now the last one is very similar to this. I want you to try this one on your own. You want to make a rectangular banner. It's 18 feet long. You have no more than 48 feet of trim on the banner. What are the possible widths of the banner? If you want to pause it and do it on your own, awesome. I'm going to draw a picture. 18 feet for each of the lengths. I don't know the widths. There's my defining a variable. Now I got to write my equation, or in this case, inequality. Again, no more than 48 feet of trim. 2 x's for the width plus 2 18s for the length. Now I have my inequality I can solve. 2x plus 36 when I simplify. Subtracting 36 from each side, 2x is less than or equal to 12. Therefore, x is less than or equal to 6. Which means the width of your banner is no more than 6 feet. And that, my friends, is it for your Inequalities Practice video. Use IXL and Khan Academy and see me if you need other practice. I'll see you guys in class.